Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to discuss about the David-Hardenberg modeling for a Cartesian robot. So without further delay, let's just jump into the problem. Okay, so this is basically a Cartesian robot with three translation axes. This is first translation axis, this is the second translation axis, and this is the third translation axis. So we are going to use DH convention to model this robot and find the transformation matrix for this robot. So first step for the DH convention, as you know from the previous lecture, is to assign the frame of references for each joint. So if we have three joint, so we will need at least 4 frame of references. So our first frame of reference is Z0 here, and this is Z1, this is Z2, and this is the tool position at Z3. So as you know, for translational axis, Z0 should be along the axis of translation, and Z1 is also along the axis of translations. For our convenience, we assume this Z1 to be positive on the left side, and Z2 positive on the downward side, and Z3 positive on the downward side as well. Now, to assign the x-axis, this for the first one, we have the freedom to choose any direction, so we have chosen upward direction. For next one, we have to use the right hand rule, so we align our thumb in this direction, and this Z1, our index finger in Z1 direction. So Z0 is basically going into the screen, so your thumb is pointing into the screen. Z1 on the left, so that means your index is pointing towards the left, so x1 should be upward direction, so this is your x1. Similarly, for x2, we put Z1 and Z1 direction, we put our thumb in the Z1 direction towards the left, and Z2 direction our index, so that means this it should be in the pointing downward index, so our x2 is coming out of the screen. And because the last one there is no joint, so basically we are following the previous joint, zx3. Okay, now to see how to choose all the DH parameters, we need to know the table, and also for the transformation matrix we have to see the generalized form of the transformation matrix. So here they are. Oh, before we go into that, we just assign the distance here, D1, this is D2, and this is D3. So these are the parameters of DH, and this is the transformation matrix for individual joint transformation. So we write down the table as follows, this one. So let me explain all these values here. So if we do the transformation from 0 to 1, so as you can see, A1 is basically Z0 to Z1 along x1. So as you can see, Z0 and Z1 along this x1, there is no change, hence it is 0. For Z1 to Z2 along x2, that means in this direction, which is coming out of this screen, there is no change, hence it is 0 as well. Similarly, Z2 to Z3 along x3, there is no change, hence it is 0. So all these A's are 0. Now let us see the alphas. So alpha 1 is basically Z0 to Z1 along about the axis x1. So z0 to z1 about the axis x1. Now if you can see, it is going towards the left. You just follow the laser pointer here. It is going towards the left to align z1, and if you put your right palm in this direction, this rotation, and then you can see it is pointing upward, your thumb is pointing upward, so that means it is correct. So that means it is in positive direction change, so which is positive 90 degree. Similarly, for z1 to z2, that means from z1 to z2 about the axis x2. So this one is also, if you use your right hand and then you move your palm, and then you can see your thumb is actually pointing towards the x2 direction, so that means this is also positive 90 degree. And then x2 to z2 to z3, they are parallel and there is no change about the axis x3, so hence this is 0. Now let's see the d's values. Okay, so d is basically your x0 to x1. d1 is x0 to x1 along z0. So x0 to x1 along z0, and z0 direction is in this direction is positive, so d1 is positive. x1 to x2, x1 to x2 is basically your x1 to x2 is basically this one, and it should be changing along z1. Now let's see, z1 on the left is positive, so our change is on the right, so d2 should be negative. Then x2 to x3 along z2, which is downward, is positive, so d3 is positive here. Now theta is z0, theta 1 is z0 to z1 about the axis x1. So z0 to z1 about the axis theta is here, x0 to x1 about the axis z0, x0 to x1 about the axis z0, no change, so it is 0. x1 to x2 about the axis z1. Now here it is, as you can see, it is, if you rotate 90 degree in this direction, then your thumb is pointing towards the right, so that means this is negative, so it is minus 90 degree. Okay, so that's why, because this direction is positive, so you are pointing towards this direction, so that means it is negative 90 degree. And then finally it is 0 because x2 to x3 they are parallel and there is no change, so hence it is 0. So now if you use this individual transformation matrix to key in all these parameters, then you will get 3 transformation matrix as follows. This is your first transformation matrix from 0 to 1, and then your second transformation matrix 1 to 2, and then finally 2 to 3. So these are the 3 transformation matrix, and if you key in all these things and you multiply a1, a2, a3, this is your a1, a2, and a3, then you will end up with a final transformation matrix as follows. Now try to understand this solution, which is quite obvious. Basically this one is your x, this is y, and this is z. So from your base axis, you can see x we are assuming upward as positive, so this is actually downward, so this point is downward from this reference, so that means this is negative x3 d3. And for the case of z, we assume this going in towards the screen is positive, so our d1 is also going in, so that's why it is positive. And now where is the y? The y is supposed to be your following the right hand rule for this frame of reference. If you follow the right hand rule, your x is your thumb, your index is y, and z is your middle finger. So that means your y is basically positive towards the right. So that's why this d2 is basically positive, because it is towards the right. And that is the end of this problem. Hope you have understood, and if you have any questions further, please do ask me or send me an email. Thank you very much.